Cool. Thanks for joining. Let me quickly share my screen so that I can show you my slides. My name is Martin, and I work at VMware on the Spring Tools team. So on the Spring team, and therefore my focus is the Spring Tools. Usually, I would be here at EclipseCon, which is one of my favorite conferences, to talk about Spring Tools and IDEs and stuff like that. But today and this year is different. So this year, I'm going to talk about sustainability, which is the other topic that is very close to my heart, and that I would like to share my thoughts and my experiences and my wishes with all of you. So in the past, I was passionate about climate change and fight climate change. So there's no need to discuss whether there is climate change or not. I think we all agree on that. So the question is, how can we all contribute to fight climate change? And for me, as a software engineer, the question was always, hey, there's software. We build software all together. And the software is being used across the globe, right? So software is really diving into every bit and every piece of the world. So we as software engineers, we have a huge impact on everything that's running around the globe in more or less every aspect. So we have a huge reach. So is there anything that we can do to fight climate change? That was one of the questions that drive me. And I think there is a huge opportunity to actually do that and contribute something to fight the climate change. In order to do that, we need to understand, where does it come from? So where should we focus on? What should we do? And of course, one of the main drivers are the greenhouse gas emissions, as we all know, and especially the carbon emissions produce the vast amount of greenhouse gas emissions that cause climate change. Of course, there are other greenhouse gas emissions as well, and maybe some are even more aggressive than the carbon, but the carbon is still the vast majority of all those emissions. So we should really think about and reducing that. And in the long run, the goal for us is, of course, as more or less with every economy, with every business, in the long run, we need to fully decarbonize everything in the software engineering world. And the question was, where should we start, and where does all the carbon emissions in the software engineering world come from? Where do I have an impact? And if you take a closer look at what are all the different aspects, all the different areas that we work in, and there is actually a wide range of topics where the software is somehow connected to and has an influence on. Of course, there's the energy production, energy consumption side as kind of maybe the major drivers and the major topics here. But if you dive deeper into the details, you see that there's, of course, where do we run the software in the data centers? How do the data centers being powered? What are the data centers causing in greenhouse gas emissions and carbon emissions specifically? What about the heating and cooling of those data centers, heating and cooling of our homes when we work from home now? What about the CPU cycles maybe? So the software runs on the machine, consumes CPU, that consumes power, causing greenhouse gas emissions, specifically the carbon emissions. What about even kind of maybe memory? Is that causing anything? What about the hardware that we use? So my question was really, the thing that was driving me, in the end, we really need to tackle all of these areas. We need to tackle each individual bit and piece and completely and fully decarbonize all the bits and pieces. Of course, I could spend hours talking about all the different aspects of all the different elements of the slide. We don't really have enough time. So I spend my time focusing on a few parts and thinking about energy production, energy consumption, and where do we consume the energy, and how can we change that? How can we change the equation and have an impact when we do our software engineering, software development, and what we do with our software? And the reason for that, why I focus on let's say the energy at the first step here in this presentation, is that most carbon emissions are actually being caused by energy production and energy consumption, of course. So the vast majority of all that is somehow connected to energy. Might be generation of electricity, it might be burning fossil fuels for transportation, or other things. And I would like to start with the energy production, because I think that's kind of an important topic to make clear at the very beginning, since you might think about, of course, energy production needs to be renewable. We need to run on 100% renewable energy one day in the future. The sooner, the better. That's no-brainer, right? That of course we need to do that. So we could kind of sit back and think, hey, yeah, let's wait for all that to happen. One day there will be 100% renewable energy, so we don't need to think about consuming energy at all. It doesn't matter anymore because everything is renewable and we are just fine, not causing any carbon emissions anymore. But the reality is that this will take a long time. We are not there yet. We are not even close to run on 100% renewable energy globally, and not even in individual countries, probably. Maybe there are a few exceptions. But this will take a very long time until we reach 100% renewable energy for all the stuff that we use, especially for electricity, but also for transport, of course. But focusing on electricity, if we take a look at the consumption rate and the increase of electricity consumption over time, that increases as well. It increases quite a bit. Even more data centers, for example, coming back to our software engineering industry, running stuff in data centers consumes a lot of energy, and that is more and more every year. So if we increase the amount of energy at the same speed, then we increase the size and the amount of energy that we consume, we will never really get there, right? So I think we need to attack this from two sides. We need to attack this on the one side, produce 100% renewable energy and try to achieve that goal as quickly as possible. But that will take some time. To achieve to reduce the greenhouse gas emissions even quicker and further, we also need to attack this from the other side. We need to decrease the energy consumption as well at the same time. Then, kind of, if we combine both, we will get there much quicker and easier to achieve this 100% renewable energy for everything and be clean in terms of carbon emissions for that. So let's look at, we should look at the consumption side. So what should we do about the consumption side? And of course, there is a lot of energy consumption happening across all the different aspects that we focus on. And I would like to pick a few bits and pieces, not talk about everything, because it's just not enough time to talk about everything. There is, for me as a software engineer, there is, and I thought about that for a long time, discussed it with many people, and it was always some sort of vague and different aspects. Oh, you should do this, you should do that, you should consume a little bit less here, a little bit more there, you should do this and that. It was really hard to find a guideline for that. And the thing that I came up over time was a simple to remember rule that we all can keep in mind. And the simple to remember rule that we all can keep in mind is try to run your software with less hardware. Try to run the software with less hardware. Keep that in mind when you engineer your software and when you run and operate your software. It is not the only goal for this is not to save on the hardware production side or save hardware or buy less hardware and save money from buying less hardware. But a lot of stuff derives from that simple rule. Like, hey, if you run your software on less hardware, it probably consumes less energy, consumes less CPU cycles, and more CPU cycles left for other processes, less memory, less network, whatever. So it doesn't cover everything, of course, but it is a relatively, I think, good and simple to remember rule. If we try to apply this rule, of course, the first action that we can take is do not run your software at all. That sounds stupid and funny. So hey, why should I write software and not run it? Of course, you would like to run it, but there's a real reason behind that. Try to not run your software, because a lot of software is running all the time, even in those times where it's not being used, right? So you run your software on the server machines all day, all night, whatever, but maybe it is not equally used all the time. And maybe you can scale up and scale down, which is kind of very famous these days with these microservices and cloud infrastructures, which is awesome. But think about really scaling that down to zero. So shutting it off completely when you don't really use it. That will save quite a bit of energy and reduce the carbon emissions down the road a lot, actually. And this is real. This is a real problem. This is not something that's, oh yeah, that's artificially, of course, you're using the software, and otherwise I shut it down. It's probably, in reality, it's not the case, right? If you take a look at data centers, there are a lot of zombies sitting around doing nothing. They're being deployed, they're run, but they don't do anything, except from they consume energy, they consume space, they consume hardware for nothing. Right? And you should really look at that, because it can have a huge impact on reducing carbon emissions of your operations and of your software. For example, there was a real case study being done by VMware for a Singapore data center consolidation last year. And when they consolidated the whole data center in Singapore, they found out at the end that 66% of all host machines were zombie machines. 66%. That's huge. That's more than half of the whole data center that could have been shut down and shut off and not consume any energy, not produce any carbon, just for free because it was not used. And that's dramatic. It's a huge impact that you can have. You might argue that, hey, VMware, they're special. They do these virtualizations, so of course they have data centers where people deploy all kinds of VMs and never use them again. But there's another study done by researchers at Stanford and other companies doing the same analysis for real companies running regular software stuff, multiple data centers, multiple companies, and looking at over 60,000 virtualized and non-virtualized physical machines. And what they found out is that in the end, when they really looked at that, 25% of all the physical servers were zombies, not used at all, zero usage of those machines, 25% of physical servers, and 30% of deployed virtual machines were not used at all. If you can shut that off, shut that down, not use that, not use the hardware, or use the hardware for something else instead of buying new or increasing the size of the data center or adding new ones, that has a huge impact. And if you look closer at the study, what is also interesting is that those are the zombie machines, not used at all. They also looked at applications, processes that were sort of in an idle mode. So were active for less than 5% of the time at all, across everything, right? CPU and network and whatever. So less than 5%. And an additional 1/3 of all the analyzed machines were in idle mode. So less than 5%. If you can condense that and get rid of those, or maybe think about why is that running in idle mode all the time? Does it really do anything anymore? Can we shut it off? It has a huge, huge impact. So really take a look at that. And that's what I mean with do not run your software if you don't really use it and if it's not really important. If you decide to run your software, try to run your software with less energy. And that means first, which seems to be maybe a bit counterintuitive, think about the memory consumption of your processes. In the past, it was always these kind of, oh yeah, memory gets cheaper and cheaper, so it's not a big deal. And it's so easy to add memory. Same applies for CPU, but we will come back to that later. It's so easy to add more memory to your processes if they run out of memory, right? Just one click away on your public cloud infrastructure provider. Just one click. A simple, easy one click. Oh, add more memory to that. Add a bigger machine to that. More powerful one, more memory. But memory, actually, it consumes energy. even if you don't use that. If you reserve memory of a specific space, for example, 1 GB of RAM, it consumes about 2 watts of energy, of electricity. If you scale that up and do the math for maybe you have software that runs in your own data center, many instances. Maybe you have software that you deploy to customers and customer data centers. Maybe your software is being used by hundreds of thousands of users, of customers, deploying your software in their own data centers, in the public cloud, whatever. You can scale that up. And if you can shave off gigabytes of heap usage, of memory usage, or maybe not even heap, but total memory usage of your applications, of your processes, the impact could be really, really, really huge. So that's really an awesome and huge impact. Very, very important. So think about that. It makes a difference. It really makes a difference. The same, of course, applies to CPU cycles, right? If you think about the CPU, of course, the CPU is one of the main energy consumption points in the data center. Let's assume some rough average numbers, 50 watts per CPU, and you can do the math again, right? You can do the math about, hey, if I don't add more cores and more CPUs to my process, if I think about, can I run that maybe with less? That makes a huge difference if you sum that up. And if you do the math for maybe multiple deployments or hundreds of thousands of customers actually using that. So it really makes a difference. And if you sum that up, there are incredible numbers, really impressive numbers coming up about the amount of energy that you consume and that you can save basically by not consuming that electricity. The third step, the third question that when to run, how to run your software is, of course, where to run the software. And maybe there are different options that you have. Of course, if you use a public cloud infrastructure, running on Amazon, Google, Microsoft, whatever, the exact provider doesn't really matter. Think about how is this data center being powered? Is that powered by renewable energy or not? For example, if you run on the Amazon infrastructure, there are certain regions, specific regions that are powered by 100% renewable energy. And there are other regions that are not powered by renewable energy, at least not to 100% yet. So maybe if you take the sustainability aspect into the equation and think about that and make that maybe not the highest priority, but one of the priorities of your decision-making, where to run the software, take that into account. It can make a difference. The same, of course, applies to your own data center, right? If you run your own data center, run your software in your own data center, think about how do you power your own data center? Do you really need to buy that much hardware, or can you reduce that, run your stuff with less energy, less hardware, less storage? That can really make a big difference. And you can, of course, switch to renewable energy providers and so on. But even that switch is not always, there are a lot of follow-up questions if you dive into the details. For example, there's this nice sentence about, yeah, my data center runs on 100% renewable energy. But there's, of course, the question, where does the renewable energy come from that powers this data center? And when does it come from which source? Is it always there or not? So that's that's important, because sometimes you just say, yeah, I switch to a renewable energy provider, but the total amount of renewable energy that is being put into the grid is not increased. You just add more consumers to the grid. So sometimes they start to compete for renewable energy without really increasing the amount. Other data centers, they put their own solar, wind power, hydropower onto the grid to make sure that the amount of energy that the data center consumes is being provided by renewable sources. But in that case, the next question, of course, comes up, does it happen all the time? Or are there times where there's more renewable energy, times where it's less renewable energy, at the moment at least, right? And there's, for example, interesting research and interesting prototypes being implemented, and some companies already adapting that, to move the workloads among data centers always to the data center that has the highest amount of renewable energy on the grid available at that moment, which is, I think, very interesting. So it's kind of your workload moves with the highest amount of renewable energy from data center to data center whenever and there are APIs that provide the data, so you can automate that. So it's not super rocket science to do that, but it's an interesting thought to think about. When you, for example, when there's a Kubernetes scheduler, a job scheduler, there's a kind of prioritization about our networks and network latency and other priorities to decide where to deploy the exact workload. Maybe you can take the sustainability aspect into that equation as well and make sure that your workloads always run in a data center or in a location where the highest amount of renewable energy is available for that to power that. I think very, very interesting things. And I think there are more things to come. And probably in the future, there are more consumers, more customers asking for that, saying, hey, if I buy your software, what's the carbon emissions that come with that software? Can you operate that in data centers with less carbon emissions and things like that? So those questions will arise in the future. I'm very sure about that. So schedule your workloads wisely, scale it down, think about where you run it, and try to run it with less energy. There is the additional question, of course, what should I do with the remaining carbon emissions that I produce at the moment? Could be traveling, employee commute, business travel, flying, consuming energy somewhere where no renewable energy is available, things like that. And there is the big topic of offsetting emissions. So you can pay money to organizations that use the money to invest in projects that have a positive impact on the carbon emissions, so that they do something to actually actively reduce, maybe grab carbon out of the atmosphere or reduce future carbon emissions. And that's sort of kind of a last resort. Some people use that as kind of greenwashing and think, yeah, I offset everything is just fine. But I think that's too easy. You should really do that as kind of a last resort. Because if you look into the details of the offsetting idea and structure, you really need to choose the projects carefully. And usually those projects are designed to have a positive impact on the carbon emissions over a certain period of time. So for example, if you put the offsetting into planting trees, which is great, right? It's a super great initiative. Planting trees, that's always great, right? You should do it. Planting trees, always good. Nothing against planting trees. But the calculation behind the scenes is often calculated in, oh, if I put this amount of carbon into the atmosphere now, I plant so many trees and I pay for the money to plant so many trees. And those trees will reduce the amount of energy, amount of carbon from the atmosphere again. But that will take 20 years for the same amount, right? So it's calculated, oh, this tree has a lifespan of 20 years. Which is good in the long run, but at the moment you're adding stuff to the atmosphere and you're reducing that from the atmosphere over a period of 20 years. So it does not have an immediate effect, which is sort of a problem, right? It's great in the long run, but it doesn't really help to fight the climate change now and in this short period where we need to reduce the carbon emissions. So focus on reducing the carbon emissions and decarbonize everything first, and just maybe do the offsetting as kind of a last resort or as an additional activity, not as a replacement for that. If you want to dive deeper into, for example, additional mechanics when you do software engineering, how you can reduce the amount of energy, the amount of memory, good principles, good practices in more detail for doing your everyday engineering, there is this nice initiative called Principles for Sustainable Software Engineering, principles.green. Feel free to take a look at that. It's just a kind of a community effort thing. You can add your ideas as well, discuss stuff. So that's, I think, that's cool. You should really take a look at that. And with that, I would like to remind you that I think carbon emissions will be an important piece of your future products and of the future software engineering that we do. And a lot of innovation will happening in that space. And wouldn't it be great if we can all be part of that innovation and do our part to save the climate? I think that would be awesome. With that, I would like to thank you with a quick run through of some of the ideas and some of the things, and really would like to encourage you to join me with that. And now I think I'm happy to answer questions if there are questions. So let me take a look at the chat window and see what's in there. Is there? Okay, so here's a question. I think that's one of the questions. How does carbon emission compare for building a new data center in a place where more renewable energy, thus building a new data center, compared to the emission of keeping the data center in a place where worse energy makes, but not having to actually build a new data center? That's an interesting question. I haven't looked into the data of actually building data centers and what building of the construction of buildings mean. But you need to be careful with the question of, should I build a new data center in a location where more renewable energy is available? Because the question applies again, where does this renewable energy come from? For example, there are companies like Google, for example, they built a data center very close to hydropower, right? So they purposely, on purpose, locate that very close to hydropower thing. But in the US, for example, all rivers are dammed. So there is no, you cannot increase the amount of hydropower that is available in that region. So if you put your data center near to that resource, you basically consume all the hydropower, and there's less hydropower for the remaining grid. So what companies are doing or are trying to do is they build a data center, and in addition to that, maybe somewhere else, but on the same grid, on the same electricity grid, they build solar farms, wind farms, whatever, where they try to produce more renewable energy and put that renewable energy into the grid. It's kind of like the swimming pool, right? You put clean water into that, and you take maybe dirty water out of that on the other end, and over time, it will be cleaner and cleaner, the water. And the more renewable energy, clean energy you put into that, the faster it is. And that's what companies are trying. Not sure if that exactly answers the question, but I hope it gives some sort of answer to that, at least to my knowledge. So there's another question coming in. Which data center is the best according to climate change rules? I don't know the exact answer for which exact data center. I know that Microsoft and Google, as far as I know, running the data centers on renewable energy. Amazon is not yet there. They're trying to achieve that as well. I think Apple is also running on renewable energy, but that's not an option for you to run your software probably in, as long as you're working at Apple maybe. But usually companies try to put out a little bit of information about that and about their efforts, but you really have to dive deep into the details and see exactly what is the public cloud data center, for example, how is that really being operated in terms of energy? Usually you can find that information, but sometimes it's a bit hard to identify that and to find that, especially if you dive into the details, say, where do exactly the energy come from? Sometimes it's just say, yeah, it's 100% renewable, but you don't really know the details. And sometimes the details matter. Okay, so I think I'm done with the time. There's one more question coming up. Feel free to reach me on Twitter. There's a Twitter handle on the slide at Martin Lippert, or there's my email at VMware. Feel free to reach out to me. I'm happy to share more details. I'm happy to share the slides, or maybe a speaker deck on Twitter later. And I'm sure that we will have, be super happy to share more details over time and improve the talk and provide more details. Okay, cool. Thank you very, very much for your attention and your time, and hope you enjoyed the talk. Thank you, and enjoy the rest of EclipseCon. Thanks.